Alright guys, welcome to 8.6, Solving Rational Equations. So this whole chapter we've been talking about rational expressions, rational functions, how to graph them, how to simplify them by adding or subtracting, and now we're going to look at solving these rational equations, and we're going to use some of the information from previous sections to help us. So the essential understanding today is when you solve a rational equation, multiply each side by the LCD of the rational expression. Find that lowest common denominator. Okay? But when we do this, you could have extraneous solutions. So you got to be real careful about checking your answers. Just because you get an x equals a number doesn't mean it's actually a solution. And that's what extraneous means. So an example of a rational equation, you need to have at least one rational expression. So x over x plus 1 plus x over x minus 1 equals 2 over x squared minus 1. That's an example of a rational equation. And so what we're going to do now is solve rational equations for x. Okay, so problem number 1. Solve this rational equation. X over x minus 3 plus x over x plus 3 equals 2 over x squared minus 9. So hopefully the first thing you're thinking about is factoring, okay? And you always have to look to the denominator because that's where the LCD is going to come from. Just like when you add or subtract fractions, you look for the common denominator. For example, 1/2 plus 1/3, the lowest common denominator is 6. So, number 1, we are going to factor the denominator of every rational expression in this equation. So we look for each one. It just so happens that there's only one denominator we can factor, and that's here, x squared minus 9, the difference of two squares pattern. So we factor that, we get x plus 3 and x minus 3, and we notice we have that denominator here. Okay, we have x minus 3 in that denominator, x plus 3 in this denominator. So the LCD is x plus 3 and x minus 3. Okay, so there's your LCD. So what we have to do now is you multiply each side by the LCD, and you can see this in red. So there's the LCD times the left hand of the equation, the left side. That's equal to the rational expression times the LCD here. Okay, so what happens is once we multiply each side by the LCD, we use the distributive property. So you're actually going to distribute this LCD to this term and to this term. It just so happens we get simplification. For example, when you multiply the LCD by this first rational expression, the x minus 3's cancel. So you're left with x times x plus 3. When you distribute the LCD to the second rational expression here, the x plus 3's will cancel. They'll just become 1. And so you would have x times x minus 3. Now, when you look on the right side, the denominators are the exact same, so they just become 1. They cancel each other out. They become 1. And so you're just left with 2 here. So after we multiply each side by the LCD, we're just left with this expression, or this equation here. Okay? We're not done, however, because we're solving for x. So I rewrote the equation up top here. It's the same one we saw. And now we apply the distributive property. Distribute the x to this x and the 3. Distribute the x to the x and the minus 3 here. And we're left with x squared plus 3x plus x squared minus 3x, and that's equal to 2. And notice how we have additive inverses here. So I cancel those out. So I'm left with 2x squared equals 2, and this is just a regular equation. Just solve for x by dividing each side by 2, taking the square root of both sides. And remember, you square root both sides, it's plus or minus. So the square root of 1 is just plus or minus 1. Now you have to check those answers, both of them, to make sure they work. And that's what I've done below. Okay, so I substitute 1 in wherever I see x, and you'll see that in red. Okay, and I simplify my fractions. Does negative 1/2 plus a quarter equal a quarter? It does. Here, I plug in negative 1 for x again, and I have does 1/4 minus a half equal negative a quarter? And it does. So your answers are plus and minus 1. There's two solutions here. They both work. our second equation and our last equation, again, we are going to solve this equation for x. And we have a little bit more complicated rational equation. So what we're going to do is we look at our equation, and number one, I'm going to factor. And I'm going to factor the numerator if I can, and I'm going to factor the denominator if I can. Okay? But I need to find the LCD when I add fractions. Okay? And we call these fractions rational expressions. Okay? So let's factor where we can. I look at the first rational expression. I can factor that down. Two numbers that multiply to be 2 and add to be 3 are 2 and 1. The second rational expression I can't do anything with. They're both prime. And what the sum of these rational expressions is equal to is also prime. I can't simplify that. So not too bad here. So I look and I see x plus 2 and I see x plus 1. Now, it's important to realize that in the last example we didn't mention this, but in the back of your minds you should be thinking about what x can be and what x can't be. Okay, that's going to play a huge part in this problem. So off the top of my head I'm looking, x can't be negative 2 or x can't be negative 1. Okay, we'd have a vertical asymptote here, and so let's just keep that in mind for later. So x plus 1 and x plus 2, that has to be the LCD. Okay, you take all the prime factors and multiply them together. Well, we have x plus 2 and x plus 1 here, and both on this first rational expression. So the LCD is x plus 2 times x plus 1. So again, multiply each side by the LCD. And that's what I've done here. Here's the LCD times the left side of the equation. And that's equal to the LCD times whatever's on the right side of the equation. Performing the distributive property, or using the distributive property again, we see that this first rational expression has the LCD in the denominator, so these just become 1, and you're left with x minus 1. Plus, we have to distribute the LCD to this second rational expression. When we do that, the x plus 2's, those will become 1, so you're just left with x plus 1 times 2x, which is right here, and that's equal to, on the right side we have x plus 1 and x plus 1, those will become 1, so you're left with x plus 2 times x minus 1. So here's our simplified equation after we distribute the LCD. So I rewrote my equation up top here. Okay, there's our equation. And now again, you have to use the distributive property. So I distribute, and I leave the x minus 1. In blue here, you see 2x distributed, which is 2x squared plus 2x, equals, and I have to distribute this. You guys might think of FOIL because it's two binomials, so I multiply that out, and I get x squared plus x minus 2. So then it's just a combination of adding like terms on both sides to clean this up a little bit. So I do that, I add my x's together, I leave the 2x squared, and I have the 1. Nothing can be added here. So now I have quadratics on both sides. So now we have to get all the terms on one side and set it equal to 0. So I bring over the x squared, the x, and the 2 to the left side. And this is what I'm left with here in blue, x squared plus 2x plus 1. After you subtract the x squared to both sides, you subtract x to both sides, and you add 2 to both sides, this is what we're left with. And we have 0 on the right. So now we have a quadratic equation, okay, and that's set equal to 0. We want the zeros of that quadratic equation. Well, this is actually a perfect square. Two numbers that multiply to be 1 and add to be 2, that's just x plus 1 times x plus 1. So negative 1 is our solution. What makes this 0? Negative 1. However, in the original problem, what I told you is that we have an x value that can't be negative 1. Okay, when you looked at the LCD, x plus 1 times x plus 2, x couldn't be negative 2 and x couldn't be negative 1. But we're saying that the answer is negative 1. That's a contradiction. So there's actually no solution to this equation. Okay, so those are two examples of solving equations with rational expressions in them. So I hope this helps you, and if you have any questions, please email me. Just in closing here, think about factoring first, finding the LCD, multiplying each side by the LCD, using the distributive property, simplifying, and getting your x. It's those same steps over and over again. Okay, so we'll see you for chapter 9.